Mr. Dueck, how do I do number 10 from lesson 1? You actually said that this was a really tough question, but you also said you like this question, you like this question, you like this question. I do like this question. I'm going to walk you through part A and part B. Part C is the same as part B, but with different numbers. So I'll let you see if you can figure out part C. Part A, it wants me to find the speed. Well, we're moving in a circle. Circular speed is 2 pi r over the period. I lifted that right from my formula sheet. And so it's going to be straight plug and chug. It's going to be 2 times pi times 5.8 over the period. The easiest value when we do go to Playland, the easiest value to get is the period, because you can just time that on your stopwatch, how long it takes the ride, if it moves in a circle, to go around once. And from that you can find V, you can find A, you can find whatever you need to. Meanwhile, if I crunch this, I'm going to get 2 pi times 5.8 divided by 10.5. And I get a speed of 3.47 meters per second. Although, because I'm going to use this, I'm going to carry a few extra sig figs. I'm going to go 3.4707. So what does that mean if I move to part B? Well, what it means is at the top, right here, if you drop the hot dog, it's going to be moving sideways when you let it go at 3.4707 meters per second. How do I know it's going to be moving sideways? Tangent to the radius. By the way, at the bottom, it's also going to be moving 3.4707 meters per second. You'll use that when you do part C, because part B says find the range. I'm going to treat this like a projectile. If I just drop the hot dog, this is the same as if we were dropping it from a cliff and launching it horizontally with a Vx of 3.4707, which means, yep, we're going to need a t-table. Horizontal, vertical. The horizontal acceleration is 0. The vertical acceleration is negative 9.8. The horizontal velocity is 3.4707. The initial vertical velocity is 0 because we launched it horizontally. We said for a split second, right when it leaves your hand before it starts to fall, its vertical velocity is 0. Now, I need 3 things to find the fourth. Oh, who remembers? What am I going to spend most of my time finding? Time. What I need is this distance here. Well, it tells me that this is 1.75 meters, and I know that's a radius, 5.8 meters. I know that's a radius, 5.8 meters. So if I go 1.75 plus 5.8 plus 5.8, or 5.8 times 2 plus 1.75, I get 13.35. I get that this is 13.35 meters. Now, when I walk over here and make it a vertical displacement, I'll need to make it negative because we ended up below from where we started. And that's the column I have 3 things in. I can find time. I'll find time vertically. How will I find time? I'll go dy equals v. Oh, vy is 0, so vyt is 0. It's just going to be a half at squared, although I'm going to write that as ayt squared over 2. This is nice because VI is 0. I don't have to pull out the full quadratic formula. I could, because this is still technically a quadratic, but I can get the t by itself without using the quadratic formula. T is going to be 2 times dy divided by a square root. If I go to my calculator and I crunch that in, I'm going to get 2 times negative 13.35 divided by negative 9.8 square root. It's in the air for 1.6506 seconds. It's in the air for 1.6506 seconds. Oh, and I can also put that in this column. And now I have 3 things I can find the range. I can find dx. How am I going to find the range? Oh, I've got some old calculations here. Let me erase those. The range dx is going to be vxt. What happened to the plus a half at squared? A is 0. So it's going to be dx equals vx. Hey, that was 3.4704 times time. I'm going to write 1.6506, but you know I'm using my answer button. 3.4704 times answer button. And if I've done this right, 5.73 meters. If I go up, there it is, 5.73. To do C, it's going to be exactly the same start. AX is 0, AY negative 9.8, VX 3.74, VY initial is 0. The only difference is here, the vertical displacement isn't going to be 13.35. It's just going to be 1.75. So it's just going to be a 1.75 here. You'll get a different time, and then when you solve, you'll get a different range. You'll get a range of 2.07 meters. So that's a nice review of projectile motion, which is also why I like it. It's good review, and also I like this question. I like this question. I'm going to put this on Teams to see who's actually looking at their Teams account.